Now, another type of coated reinforcement. So, until now we were talking about item 6 and item 7, right? That is epoxy coated rebar and CPC coated rebar. They were non-metallic materials, which had a lot of problem because of the abrasion resistance, right? Now, here we are talking about hot dip galvanized or HDG steel reinforcement, which is having very good abrasion resistance. Okay, it's a bit costlier, but still the product as such is good, because at the construction site we handle them with very rough manner. Okay, so you will walk over it, you will drive vehicles over it, you will park vehicles over it, all sorts of things you will do to the rebars. So they have to sustain all those, and there should not be any scratches. So non-metallic coating in general is not a good idea for our typical construction sites. Okay. So metallic coating is what we need to go for. This is an example. Now zinc, here galvanized steel, what essentially it is, it's a zinc bath with about 450 degrees Celsius. So the various processes are there. Basically you dip the steel in a zinc bath at about temperature which is 450 degrees Celsius. So at that time what will happen is hot dip, no? What will happen is the zinc will adhere to the steel surface, and this is a microstructure for that. You can see here zinc, 94% zinc, 100% zinc, 100%, then 94%, then 90%, then 75%, and then the base steel. Okay. So as you move downward, the concentration of zinc keep reducing. So you have, but anyway, you have as a layer, as a whole, it performs very well. You have a lot of zinc there, which will protect the steel from corrosion. Okay. And more importantly, protect the steel from corrosion, and also it has very good high abrasion resistance. So than the non-metallic coatings like fusion bonded epoxy coating or CPC coating. Okay. So metallic coating is better because it has abrasion resistance and corrosion resistance, because here we use zinc as a metal, and zinc will corrode before the steel corrodes. So that's like a sacrificial thing, but okay. But zinc will protect, and its corrosion resistance is better. And also you can see here in this pictures, this white line around, this is the cross section of a rebar, this white line around that indicates that even if there are sharp corners, they still have good full layer of proper coating is there, okay, of the zinc coating is available, even if you have rough edges. Like imagine you have a rebar right here, you have, these are all rough edges, no, very sharp corners, etc. So they are all in that corner region also, you need to have proper coating. That is very clear from the pictures on the top, that when you go for galvanized coating, you can really have very good coating, okay, which is probably not that easy to provide when you talk about non-metallic materials. And also zinc has very high chloride threshold. In other words, zinc will need 2 to 4 times more chloride contamination to corrode. So that means when you put a galvanized steel in concrete, it will need double the amount of chloride or 4 times the amount of chloride for that steel to start corroding, because only after zinc the zinc coating corrode, then only it will reach the steel. So if the zinc coating is preventing the corrosion, definitely the steel inside is also getting protected. Now when you talk about the carbonation induced corrosion, again the pH threshold, the concrete gets exposed to carbon dioxide and chlorides, and then the carbon dioxide reacts with the concrete, and then pH of the concrete will decrease. When the pH of the concrete decreases, the steel inside can start corroding. Okay. Now when you put this galvanized coating, that amount of pH reduction is also significantly high. So you again have very good protection against carbonation. So more things I am not going into detail. You can read about chloride induced corrosion and carbonation induced corrosion if interested. But for you, for this class, you need to remember that the chloride threshold or the amount of chloride required to initiate corrosion for galvanized steel is more than that for the uncoated steel, and the amount of pH reduction required is more for the galvanized steel than the uncoated steel. So, in both these two major corrosion mechanisms, the galvanized steel perform better than uncoated steel, and also because of the high abrasion resistance, these steels are very good. Abrasion resistance is very high, corrosion resistance makes this type of bar a good choice for durability. Okay. However, there is a consideration for cost. It's sometimes twice that the cost is double in some because of the various factors. Okay, manufacturing is not that easy, etc. But if you look at life cycle cost instead of the capital cost, then you will see that these kind of bars are actually durable, and then it's beneficial in the long run. Life cycle cost. So, these are some examples. This photograph is from a temple in Chennai where they have used galvanized steel, and this temple is like about 50 to 100 meters from the seashore, very close to the seashore. So, this was the only option to really have a long lasting structures. Okay. Now, this comparison of the cost. Conventional steel, if cost is 1 unit, for epoxy coated steel it is about 33% more. Okay. For galvanized steel it is about twice, double the cost. Stainless steel 6 to 7 times, and if it is clad stainless steel 2.5, but that I am not going to discuss much because these are the stainless steel rebar which were used very earlier, now not in much use. There was like a thin layer of stainless steel coating was provided on. They used to do this, but not anymore. I mean, it's not widely used nowadays. So, the clad steel they call it. Okay. Anyway, let us focus on these first 4 of them. You can look at the cost comparison, and then you can look at the life cycle cost. When you make choices, you have to look at life cycle cost. Okay, not just the capital cost. That is very, very important. Okay, now until now we were talking about steel rebars. Now, there are also pre-stressing strands. When we talk about very long bridges or high rise buildings with large span, the span means the distance between column to column, in auditoriums, etc., or high rise buildings where you have the roof where that need to be very thin and long span so that you get more space on the floor, less number of columns. In such applications, bridges, in such applications we use something called pre-stressing strand. Okay. These are the strands which has about 4 to 5 times more strength, 4.5 times more strength than regular steel. Okay. So, regular steel, if the yield strength is about 415 or something, let us say 500, this is 1860 and all that, that is the range you are talking about, very high strength. So, they come in typical 7 wires, you can see here 7 wires of different diameters, and there is also one with 3 wires. Okay, there is one with 3 wires also at the bottom left. Okay, we will see where these type of strands are used. Okay. So, this is how a strand looks like, top right you can see, and there are also sheathed strands. Okay. Sheathing means like a plastic pipe or conduit put around, and in between they will put grease. So, that strand gets very good corrosion protection. So, they will fill grease, this coating, it there are also coating or grease is also used. Okay. Okay. Now, there are unsheathed or uncoated strands and coated strands also, and you can see the number of wires. So, this is the typically how these strands are supplied, because these are used for long structures, long span. So, you cannot really have a 10-meter long piece or anything like that. You have to have it in a spool or in a this is called spool. You have to have it this circular, and then so that you can use the same wire starting from one column to another column which is far away. Okay. 35, 40, 50 meters long, it's possible. So in metro construction, this is heavily used. I'll show some pictures where are these type of strands used. Like the 3-wire strand I showed in the previous slide, this one on the bottom left corner, okay, 3 wires, no, that is used for railway sleepers, widely used for railway sleepers here. And all other things which you see here, the typical type of wires are the 7-wire strands. Electric post, when they become very tall, a very tall electric post, typical rebars may not be sufficient. You need to have very high strength strands. So that's one application. And long span bridges, you can see here, this is a bridge in Bandra Worli in Mumbai, and many of the flyovers which we see today, they are using pre-stressing strand. This use of pre-stressing strand is becoming very widely used in most structures, high-rise buildings. So you can see the floor of this high-rise buildings, beams are also sometimes used with made with pre-stressing strand. So this is the sheet strand which I said that it has grease coating. You can see grease here, right? So it's a steel strand coated with grease and then put inside the plastic pipes, flexible pipes. And then also nowadays we have this epoxy coated strand. So be very careful when we use this epoxy coated strand, and that is why I put the picture here. We know very well that epoxy coated bars or rebars are not performing very well. So let us not create other problem by inadequate providing epoxy coated strands. See, the thing is, these are all technologies which are very good, but provided the implementation is also done in a good manner. Okay, if you cannot have a good protection, and if you cannot follow the good quality control measures at construction sites, then you should not use them. So all coating materials, you have to ensure that they are not cracked, they are not exposed to sunlight, they are not scratched. Okay, all these are very important. And it is better that you provide an abrasion resistant coating than a non-metallic coating which is bound to get scratched and the way we handle things at the construction sites. So it's not at least it depends on whether I'm not against the technology, but what I'm saying is when we use a technology, you should use it with full quality control measures also in place. Okay. And these are some examples where we use this kind of strands and cables also. So this is a threaded rod, okay, pre-stressing, and then these are the 7-wire strand. Then you can see here cables. These are all cables. So I would like to mention. So when I say 7 wires, so this is wire, 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 wire. Each one of these is wire. 7 wires are put together to form one strand. Okay. Okay, so that is 7 wires. Okay. Now on the things on the right side, you can see one set of wires are placed, they are placed in a coaxial manner. Okay. So you can see here, this is another round. So they are actually cables, we can call them cables. These are used, as you see in this picture here, this picture here. These are the cables which are used for that. Okay. So you can see these are the cables for cable stayed bridges. When you put the strands inside the concrete, then we use these strands. Okay. So you have to see where a cable is used, where a strand is used. Okay. Or both are not same, they are different things. Now, so this example for the railway sleepers I told you earlier. So you can, sleepers are these concrete pieces on which the rail track is sleeping. Okay, the two steel tracks which you see, this rail track, they are actually sleeping on the sleepers. So we can call it like that. Probably that is how the name came. So you can see these little black thing on the picture on the right side. These are the pre-stressing strands. So these are those one with 3 wires. Okay, 3 wires. Okay, 3 wire strands, and then we have threaded bars. Okay, these are mainly used for geotechnical applications, where for example slope stability, or where you will have especially in tunnel constructions, where you will have these rods which are anchored into the you have this steel rods which are anchored into the ground or rock strata, and like a nail, and then you anchor it and then you tighten from the other end. So for more details, I would request you to go and read out in the textbooks or internet. But you can look for anchor rods. Okay, threaded bars are used. So you can see these threads are here. No, you can see the threads over there, and these bars, and then with nut and bolt system they are tied. Okay. Now let's look at some of the properties which we should be testing while selecting these rebars, strands, etc. Okay. So these are some of the images which you are already familiar with. We covered this earlier, nominal stress, true stress, etc. But the point which I am trying to make here is there is this parameter yield stress, ultimate stress, and the modulus over the slope here. Okay, yield stress, ultimate stress, and then the elongation also. These are all different things which we have to look at. Okay, the length or percentage elongation you will calculate. Okay, based on the strain which you get, you can calculate the elongation of the rebar specimen, and the yield strength you can calculate by this 0.2% offset yield strength, and then slope of this you can take for calculating the modulus. So just giving you some recap on what we have discussed in our earlier lectures. So these are all things which we need to test. Now there is a specification which I already mentioned. IS 1786 is the IS standard or Indian standard specification, published by Bureau of Indian Standards, BIS, and this standard is widely used, and for this standard provides both mechanical and chemical properties which are required for the steel reinforcement. Now look at here on this, there is table 3 in this standard, where you have FE 415, 415D, 415S, 500, 500D, 500S, 550, 56 up to 600. And there are, you see these letters D and S also. Okay, so for first three, if you see, all these three are 415. So the yield strength is 415. That means yield stress here, it is 415 for this steel. But then you have this D and S there. What is D? D stands for enhanced ductility. Okay, and S stands for enhanced strength ratio. So what is that ratio? Ratio between ultimate stress and yield stress. Okay, ultimate stress and yield stress. That is the strength ratio. Now what is this number 415? That is the characteristic yield strength. Okay, characteristic yield strength. Okay, so I am going to call it characteristic yield strength. So we use that number for our design purposes. Okay. Characteristic value we have already discussed earlier. Okay. So this characteristic value is something which kind of gives you an assurance that that much will be the strength. So what is a characteristic value? Is a safe value at which the probability of failure is acceptable. Okay. Characteristic value is a safe value at which the probability of failure is acceptable. Okay. So when I say yield strength of a particular bar is 415, what that means is about 95 to in case of steel we can even call it 98% chance that the strength will be 415, at least 415 MPa. So it's like a guaranteed value which you can get. Okay. Now also chemical composition, there is table. So this is extension of the same table which I just showed you in the previous slide. You can see what are the limits. So 0.2% proof stress should be 415, 415, 415 for all these three steels. Okay. I am trying to show you how to read this table. Don't try to memorize any numbers in this table because you have this table all the time. But you need to know how to read the table. Okay. For any of these codes, we don't want to memorize things, but we should know that where to look for what information. Okay. Now in the 500 grade steel, that means the characteristic yield strength is 500. Okay. And in 550 grade and 600 grade steel, the 550 grade steel, and then you have 600 grade steel. So these are all the numbers which indicate the characteristic yield strength. And then you have also an upper limit for that. So the item for row 1 is kind of a lower limit, right, the minimum value. Now row 2 shows the maximum value, an upper limit for that. But it is not for all the grades. You notice that here it is missing, only here it is provided, here it is provided. So only cases where the strength S grade steel, there is an upper limit for the yield strength. Okay. And then you have the tensile strength or ultimate strength divided by the yield strength ratio. So you can see that it should be greater than this value, greater. So there are these specifications. So if you are looking into the market and then try to buy a particular rebar and somebody says it is Fe 500D grade steel, then you have to look at this column and see whether that is matching all those requirements or not. So that's how we use this table. And then also you have for the ductility part, we look at total elongation, how much when you pull a rebar, how much it gets elongated by percentage. Okay. So these are all different things which you have to look at. And also in terms of, so the previous table was more on mechanical properties. This is more on chemical properties, where you look at chemicals. What are the different chemicals which are kind of present in the steel, or how much there should be, because each of those chemical has influence on various properties. You can see here carbon, it affects the hardness, it affects the strength, it affects the weldability, brittleness, etc. And different range of carbon, if the carbon content is more than 0.3, then it becomes unweldable, okay, or it becomes brittle. And then manganese, it affects the yield strength, sulfur affects the brittleness, phosphorus affects the strength, okay, and also it affects the corrosion resistance, copper definitely corrosion resistance, phosphorus also corrosion resistance. Okay. Then chromium also weldability and corrosion resistance, so carbon equivalent. So different chemicals can have an influence on the various properties of the steel. Now for this, again IS 1786 has some specifications. They say for Fe 415 steel, this should be the maximum or upper limit for various composition, various chemicals. If you have carbon content more than 0.3%, then you cannot call it Fe 415 steel. Okay, it is not Fe 415 steel in that case. So you have to make sure that this carbon content is less than 0.3, the sulfur content is less than 0.06, phosphorus is less than 0.06, sulfur is plus phosphorus is less than 0.11. So all these, for each of the grade steel, each of the designation, you have to make sure that the steel is actually meeting these requirements. And they do test all the manufactured steels when they sell out. When they ship the steel out, there is also a test report which comes along with that. You should ask for that. Okay. So when you get the test report, and you can also test it in a third party, somebody else can do the testing. Once the steel comes to the site or before that, you should routinely check all this. Okay. And carbon equivalent, mainly affects the weldability. You can use this formula on different chemicals, how they all actually influence the weldability, mainly for guaranteed weldability, because if carbon equivalent goes higher, then you can't really weld that steel. Okay. So, these are all different things which we very commonly or routinely test in the steel construction steel industry. Okay. Now, diameters, that is also we say different diameters. It is not like, you know, if you do a calculation and you say that okay, I want a steel which is 10.56 millimeter diameter, you can't get that. So, you have to go for the standard sizes which are available and then accordingly you have to design. Okay. So, typical sizes which are available or nominal sizes which are available are this. Okay. So, what is a nominal diameter? It is a value, different definitions are, I just looked at dictionary and found these different meanings for nominal. It is a value existing in name, it is not a real value. If you actually take a 10 mm diameter bar and then you try to measure the diameter of the bar, it may not be 10 mm at all, but it will be minimal at least 10 mm. So, but slightly more than that. Okay. So, what those numbers are essentially is just a convenient designation. It is easy to call, you know, for naming purpose etc. it is easier. Okay. Usually they use a round figures and it is an accepted or a goal or an approximation. So, when I say a 10 mm bar or a 12 mm bar, it is just that I have roughly about at least 10 mm I will get. So, but these are the typical you know, it is not at least means at least and about that number. Okay. So, if I have a 10 mm bar, I will know what is the cross sectional area and what is the unit weight of that rebar. So, I can calculate how much will be the weight of the structure if I use that, and so many things you can calculate. Now, also another test which we have to do is, so I talked about the chemical test and mechanical properties, especially the tensile. Now, we also should do bending test, because in the site you will always bend the rebar, right. For ductility requirements you will have stirrups, which is the bar which goes around and which are bent, you know, and those bars when you bend it should not crack. If it cracks then it is not good, no. We discussed that in the previous lecture on TMT steel. If the coating is not good then it will crack, and then people actually do this bending test and then see whether it cracks or not. This is an example of how the test should be done, but also when you bend it, this is something called mandrel. Okay. So, you put this bar and then try to bend it around that mandrel. So, why I am showing this here is I have seen many places where they bend the bar with a very small mandrel. So, what will happen is the bending will be very sharp. Okay. And when you have very sharp, the bars will crack. So, there are recommended mandrels also, like, you know, at the site when you bend the bar, you should also use a sufficiently wide diameter for bending purpose. Okay. So, these are very important tests for various rebars. We should do tensile strength test, try to find what is the yield strength, what is the elastic modulus, what is the elongation, you know, tensile strength, yield strength, elastic modulus, elongation which indicates ductility. These are all mechanical things, right. Now, also corrosion resistance is very important. Of course, chemical testing is there. Corrosion resistance, especially when you go for TMT, you should go for TM ring test. Very simple test, I showed a video in the previous lecture. Okay. Very you know, you can just very easy to do test. Now, coated rebars, if you are using coated rebars, they claim that you will have high corrosion resistance, but that high corrosion resistance is only possible if you have a good quality coating. So, you have to look for abrasion resistance, characteristics of the coating itself, all these have to be tested. Okay. Peeling, the coating should not peel off very easily, they should not crack very easily. Okay. They should not crack, they should not get scratched, you know, under exposure to sunlight etc. All these have to be tested. So, the main message here is we have some responsibilities as engineers when we use materials for construction. Okay. One responsibility is, this is not the only two responsibilities, there are so many responsibilities, but two such responsibilities are, we must understand the mechanical and durability requirements for that particular applications, and then decide appropriate test methods. We will have to think what is the exposure condition, what is the load conditions which are coming. So, accordingly you have to decide on, okay, these are the mechanical properties required, these are the durability properties required, or corrosion resistance or something like that. Okay. Now, this is the design office will tell, okay, these are the things which you have to do. And then we also must check if the claims made by the manufacturers are actually being met by the products which they supply. So, that is why we must test them also. Very routinely we should test. If you are buying like thousands of truckload, or let us say lot of material, you cannot just do one test and say that all that material is of same quality. So, you have to take samples from here and there, and then like in case of concrete we will say every truck you should have so many cubes made and test it. Like that, steel also you should take, every lot you should take one or a couple of samples, and then lot is like the bundle of steel, and then you should do the testing for mechanical, chemical, corrosion resistance, etc., etc. Okay. These are very important. As an engineer we must practice. We should not just believe what the manufacturers are telling. We should be able to test, that is our responsibility, and make sure that the products which you use in construction are of good quality. To summarize today's lecture, we looked at coated reinforcement, we talked about the challenges associated with the non-metallically coated rebars like fusion bonded epoxy coated and CPC coated rebars, and then we also talked about how better the galvanized steel rebars are, especially because of their better abrasion resistance and galvanic protection properties. Then we talked about pre-stressing steels and some test methods we talked about, and then our most important thing, our responsibilities as an engineer. Okay. I think with that we will close today. Thank you.